Okay, this is an example of cubic function. Okay, cubic function, similar to linear function, is also quite simple to do. So first of all, we have to find F inverse. In order to find F inverse, I will play with the property F of F inverse. F composite of F inverse of X is always equal to X. So over here, I will have F inverse of X, everything power 3, plus 1 equal to X. So F inverse of X, everything power 3, is equal to X minus 1. In order to get rid of this power 3, what I can do is, I just do the third root for both the left-hand side and the right-hand side, because I have to be fair. So now at the left-hand side, I have the third root and also have a cube. So this means that I'll get back the original function. So now I have F inverse of X to be equal to the third root of X minus 1. This is my inverse function. Now for part B, sketch fx and F inverse X. Sketching fx, we have no problem with that because we have done that before. So first of all, I'll draw my axis. Since I have to draw fx and also its inverse, I will not label my vertical axis as fx or F inverse x. I'll label it as y. Don't forget the origin. I'll start by drawing my fx first. This is a cubic function. A is equal to 1, so A is positive, so this means that it will look like a snake going up. Okay, over here there is no bx squared, there's also no cx, so I can play with translation. So here I have plus 1, so this means that my graph, by translation, it will go upwards by 1 unit. So here I can have my point 1, and my graph looking like a snake, it will look something like this. Oops. And my graph will look something like this. Okay, don't forget to label your graph. This is fx equals to x cubed plus 1. So in order to draw my F inverse, I have to draw the line y equals to x first. So by drawing y equals to x, when I have x is 1, y is also 1. X equals to 0, y is also 0. So my graph will look something like this. So here I have y equals to x. Okay, here I can extrapolate my fx graph, so it will cut my y equals to x. So over here, notice that my fx graph will cut the x-intercept. Okay, so since it cuts the x-intercept, I have to find the x-intercept. So at x-intercept, fx is equal to 0. So I have x cubed plus 1 equals to 0. X cubed equals to negative 1, so x is equals to negative 1. So over here, this will give me negative 1. Now I already have my fx. I also have the line y equals to x. I can sketch my f inverse by reflecting my fx along the line y equal to x. So the easiest way to do it is by playing with the intercepts, the point at the intercept. So this point over here, the coordinate is 0, 1. After I reflect it along the line y equals to x, the value of x and y will swap places. So the new point now will become 1, 0. So it is over here 1, 0. So this point at fx, when it is reflected, will be here. Okay, I'll write down the coordinate 1, 0. And now the second point, the intercept here, this coordinate is -1, 0. So when it is reflected along the line y equals to x, it will swap. Okay, the value of x and y will swap. So now the new point has the coordinate. So now the new point has the coordinate 0, -1, which is here. Okay, this is the original point, and then when it is reflected along y equals x, that point will be here. Okay, so now I will use my blue pen to draw this line. My graph will be symmetrical. Okay, you can perfect it to draw it nicer. Ooh. Now I can label this as f inverse of x to be equal to the third root of x minus 1. Okay, so now we move on to part C. Find the domain and range of fx and f inverse. So for part C, look at the red graph. So most left is -infinity, most right positive infinity, open, open. And my range of f, most bottom -infinity all the way upwards is positive infinity. Domain of f inverse, again, when we reflect it along the line y equals to f, when we reflect it along the line y equals to x, my f inverse will become f. D refers to, domain refers to my value of x. So when it is reflected, it will become y. Y refers to the range. So range of f is also -infinity to positive infinity. And lastly, my range of f inverse, when I reflect my f inverse, it becomes the function f. Range refers to value of y. When it is reflected, it will become my values of x. So x is my domain. So domain of f over here is -infinity to positive infinity. Okay, so this is how I do for my cubic function. This is how I find the inverse for cubic function, how I sketch my cubic function, as well as how I find the domain and range for cubic function.